The YouTube streaming?
Yeah, now only I'm doing.
Okay. So shall we start, sir? Madam, shall we start?
Yes, ma'am, sure. We can start.
Okay.
Yes, ma'am. Yes, ma'am. YouTube channel I enable.
Okay, we'll start, sir. Well, so a very good morning to all of you. It's my pleasure to be part of this event and propose the welcome address. On behalf of RMK Engineering College, I wholeheartedly welcome our guest, Dr. Suganthi Srinivasan, Senior Product Technical Lead, Valeo India Private Limited, Chennai, for the generic talk series on From Data to Decisions, AI in Autonomous Driving and ADAS, hosted by RMK Engineering College. Thank you very much, ma'am, for accepting our invitation and for your gracious presence. A warm welcome to our respected principal, sir, who has guided us meticulously in all our activities and making the event a grand success. I also welcome all the head of the departments, professors, Professor of ADAS, Dr. G. Manikandan, Dr. P. Shobharani, faculty members, and dear students. I'm sure that this session on autonomous driving will be an eye-opener for each one of us to prepare ourselves in AI. Once again, a very warm welcome to our guest today, and it is a great privilege for us to have you here for the generic talk series, madam. Now, I request our professor, Dr. G. Manikandan, to introduce the guest and felicitate. Thank you.
Good morning, ma'am. Good morning, everyone. It is my great pleasure and honor to introduce our esteemed resource person for this generic talk, Dr. Suganthi Srinivasan, ma'am. Dr. Suganthi Srinivasan, ma'am, is a distinguished expert in the field of computer vision, AI, image processing, and automation system. She currently serves as a senior product technical lead at the Valeo India Private Limited, Chennai, where she leads advanced research and development initiatives in precision algorithm for ADAS and automation vehicle system. With over the decade of rich experience spanning both industry and academia, Dr. Suganthi Srinivasan has made remarkable contributions to next generation vision-based system, including object detection, semantic segmentation, multi-sensor fusion, and infrared image technology. She plays a key role in developing intelligent parking solution and safety critical automotive features using deep learning and multitask network. Dr. Suganthi Srinivasan, ma'am, completed her PhD in medical image processing from the prestigious Indian Institute of Technology, Madras, where her research focused on early detection of breast cancer using infrared thermography and advanced image analytic techniques. Her work bridged healthcare innovation and automation intelligence, demonstrating her multidisciplinary expertise. She holds a multiple patent, both granted and filed in the area, such as infrared perception system, emergency vehicle detection, and AI-driven multitask learning framework. She has also received consecutive innovation award at Valeo for her outstanding contribution to technological advancement. In addition to her industrial leadership, Dr. Suganthi Srinivasan, ma'am, has published several research papers in reputed journals and conferences and has mentored doctoral scholars, contributing the significant and academia industry collaboration. Her journey reflects excellence in research, innovation, leadership, and mentorship. We are truly privileged to have such an accomplished professional with us today to share her insight and expertise. On behalf of management, principal, and HOD madam, I extend a warm welcome to Dr. Suganthi Srinivasan, ma'am, to invite her address the gathering. Thank you. Now I hand over the session to our resource person, Dr. Suganthi Srinivasan, madam. Please, ma'am.
Thank you, sir. Thank you for the introduction. Thank you, ma'am. I will share my screen. Is my screen visible?
Yes, ma'am.
Hope so. I'm audible as well.
Yes, ma'am.
Yeah, audible.
Good morning, everyone, and welcome to the session on data to decision in AI and autonomous driving and ADAS. ADAS is basically advanced driver assisting system. So basically, my background is completely from the perception design and implementation of perception algorithm for ADAS and autonomous driving. But though I would like to touch upon the rest of the modules that will give the complete solution for autonomous vehicle, because we want to touch the importance of AI and data that has been effectively utilized in bringing up such solution for real-time implementation. So already there was an introduction about me. So myself, Dr. Suganthi Srinivasan. I'm currently working as a senior product technical lead from Valeo India Private Limited. So to give a background about our company, it is an tier 1 company working from head office from Ireland, and we provide solutions for perception algorithms. We have multiple sensors, supporting sensors in order to deliver the perception solution, end user functions, products, and etc. for automobile industry. So moving on. So this is my agenda for today's talk for the next 1 hour. So I will just give an introduction to ADAS and autonomous vehicle, and how AI is playing an important role in automotive, following what we are talking as data, and the general architecture of ADAS and autonomous vehicle systems. And since my background is completely from perception system, I would like to prefer to cover the AI, the use of AI in the perception system design and implementation. And I will touch upon the other subsystem guidance, navigation, and control. And just to give an insight, what else we have in the autonomous automobile industry to take forward for AI and data science. And also finally end up the session with challenges and what is there next for us, for the younger generation to take over. So to start with, I want to just give start with the solution that we offer from Valeo. So basically, these solutions are AI-based solutions, what we are offering to different OEMs like BMW, Volkswagen, Geely, GM, and so on. Many OEMs we are offering. So the one which is currently playing here on the left side, you can see your vehicle is moving autonomously. It is basically a parking solution where we want to detect when you go for a parking a vehicle, you can see multiple objects on the road. So if I have an autonomous vehicle, then it should able to detect that obstacle on the way, and it should brake accordingly. So this is a solution which we have from AI-based solution, where the vehicle is capable to detect the obstacles that is in front of the vehicle while in the parking scenario, basically. So this is our vehicle. It drives autonomously. It can detect all the objects on the road. So here in an example where it is detecting a pole and also a pedestrian when it is taking a reverse. So you can see clearly how we are detecting. It is basically an AI-based algorithm, perception algorithm. So we detect, we have a rear camera surrounding the vehicle, which will capture the environment, and we detect the pedestrians and apply the brake if a pedestrian is there on the way. So another solution here you can see it's a completely trained parking solution. So it runs autonomously. So for example, if I daily I go to office and come back to home. So when I reach the home, from the home to the garage, if it's a known parking environment, so I can train the vehicle. I can drop the vehicle at the entrance, and it can go automatically park inside the garage. And when I access it remotely, it can come out of the garage till the home. So this is such kind of a solution for parking system. It's an automated parking solution. So it has a facility of saving a certain number of path from point A to point B. So at the very first time, we need to record the path. So here the recording is happening now. Once it is recorded, till the recorded the environment from path A to path B, the next time onwards, it will automatically park. So we are supporting multiple slots, like we have variety of slots, right? Perpendicular, parallel, fishbone slots. We are supporting multiple slot types, and also the objects combined together, it will do automated parking. So along with this, we have an additional feature also, back drive assist. Suppose we are ended up with the traffic where we can't move forward further. So the car can take autonomously reverse up to 200 meters. So these are some features which I can say all are AI enabled, AI based solution what we are offering from Valeo. So this is two different OEMs. This is one of the solution where we have the complete automated parking system that is from our company. So getting into the today's talk. So so far I have given a glimpse of idea or insight how what is meant by autonomous parking, or what is meant by what we how we use AI for our solutions. So to introduce further how what is the role of AI in automotive, just I want to give a background, like what is ADAS, what is autonomous vehicle. So when I say autonomous vehicle, the vehicle is capable to move autonomously without a driver, without any interruption from the driver or any human inputs. So that is what the autonomous vehicle means. So it is capable to sense the complete environment. As a human driver, when he drives the car, we normally look into the environment and hear the sound. So our perception system should act as a eyes and ears of a human driver, and it should capable to sense the environment and do the maneuvering automatically. That is called autonomous driving or autonomous vehicle. When we say ADAS, it is an advanced driver assistance system. It is basically an electronic system, which is capable to do a particular task, not the entire task that a human driver can do, a particular task in order to give a assistance for the driver. So it's very difficult for a human driver to see a 360-degree perceptions around the whole vehicle. So having a visibility around the car is one of the ADAS solution, which we can say like help the driver to see at the blind spots. So like that, we have many ADAS solutions, individual ADAS solutions that can support driver. So these, apart from these two, we have another category called as active and passive safety systems. So mostly active safety systems is basically to reduce the when there is a probability of going and hitting an object, it will protect the passengers inside the car. Already you have seen so many airbags, seat belts, etc., which is already there in the vehicle. So active safety system is something like whenever we are going to hit an object, it will apply the brake automatically. Passive safety is something like that, seat belt and airbags. Though we hit the obstacle, we will be the passengers inside the car will be saved. So these are the different solutions that are offered in the automotive industry in order to ensure the human safety while driving. Not only the human safety who are sitting inside, but those who are outside the car also. So in order to ensure the human life and to ease the driving, these are the different solutions we offer. So there are, you might have seen multiple solutions already existing in the recent mid-range and higher end cars. So all these currently, whatever we have falls under ADAS system, while autonomous vehicle is still in research to come up to a commercial use. So why AI in automotive? So basically, when we say why we need all these features in the automotive domain, in order to make the efficiency. Otherwise, I can say to human driving safety. We can say it is basically to avoid the road accidents. Most of the accidents that are happening in the current scenario is mainly due to the human error. Human error. So either we miss to see the obstacle or a pedestrian crossing the road, or it may be due to some error the human normally makes. So in order to handle or in order to reduce such human error, these ADAS and AD solutions will be much more useful. And also to efficiency. So when we have the proper AI-based solutions, we can have a proper planning for the vehicle to have a smooth maneuver across the path A to path B. And also accessibility, any users can access, even old age people or even a person with disability. So even those people can also access if we have more solutions to help the driver. Of course, intelligence, AI enabled means along with the human intelligence, we have and machine based intelligence also that will help us to take a decision in a very crucial time instant, I can say. And also it is support. If my entire where I have I'm living in a city where I have the smart appliances installed, then it is easy for me to support to get into the AI-based solution for the vehicle. So of course, it completely transforms the ecosystem into safer and smarter and smooth transition. So when I say in automotive, we have different levels of autonomous to achieve this autonomous driving. Level 5 is the complete autonomous vehicle, what we discussed before as an autonomous vehicle, where there is no driver at all. But level 1 to level 4 is something like we have an incremental way of introducing an autonomous to the vehicle. So level 1 will have either either very minimum driver assistance system, either by using a radar or by using a camera sensor. And level 2 is a combination, like it is capable to control a small thing, like if you say ACC, adaptive cruise control, which you have seen in the vehicle. So it is just like when you're driving at a highway, if there is some obstacle that is coming in between, it will indicate the driver either to reduce the speed or to handle it, or it will apply the brake automatically. So like that we have different levels. Level 3 is more advanced, so it can do autonomous parking by itself. Is level 3 solution. What we are offering is level 3 solution. We are moving into level 4 now. Level 4 is something autonomous, equivalent to autonomous vehicle, but a driver should be there in order to take the control of the vehicle at a very critical situation. So how we are able to achieve this level 1 to level 4 or level 5 level of autonomous driving is by using the data. That is whatever data we see. So when we drive the vehicle itself, we can see multiple information that is available in the environment. So that information is going to help us to drive the vehicle autonomously. How? By using AI-based solution. So in this era of having the facility to use AI-based solution plus the data that is available in the environment, we could be able to move from level 1 to level 4 and even level 5. We are moving towards level 5 now. So the very first stage, when we take level 1 and level 2 and all, it will not support all AI-based solution, because even the processor what we are using for achieving level 1, level 2 solution is very small one, because it has to fit in the car and it should be cost effective for the consumers. So it will be a small rule-based algorithms which can support, which can be implemented and can be achieved. Small things which can help the driver can be achieved by using a rule-based algorithm. But when I want to take the control of the vehicle, I need some intelligence to be given by the algorithm. So then we move on to the AI-based solution, where we have some intelligence that are trained and it can be used along with the human intelligence in order to handle the situation. So from AI-based solution to we are going towards level 5 by having a more advanced technology which is available currently now. So we already started moving from traditional rule-based system to a real to AI-based solution, only to handle the real-world complex scenarios. So if you think about driving a vehicle in India, where we have a more highest population and also a different driving mentality with the people, it's very difficult to handle that kind of scenarios by the autonomous vehicle. So to handle such kind of real world complexities, we need some kind of an intelligence system along with the human system in order to make the driving more safely. So instead of having a rule-based system, when we move to the higher level of autonomous automation, we use more data from the environment in order to in order to use the intelligence system there. So when we say about using cars using a data, so when a human drives the car, what data we see? We can see a vehicle vehicle in front of us going at a specified speed, a pedestrian walking along the side road, or a pedestrian is intended to cross the vehicle, so cross the road. A bus is going to come opposite in a different lane at a different speed. These are the information which we see. So how these data are captured and how this data are captured and used for the vehicle to learn, used by the AI to learn and control the vehicle is what we are going to see in the next slide. So how the vehicle is used as a data machine. So for anything, if you want to drive the car, if you want to apply the brake also, your human eyes and ears will be used for sensing the environment. So when I want to have an autonomous vehicle which is capable to make a decision on itself, I first need to understand the environment. To understand the environment is what we call it as a perception. So to perceive the environment, how we see the environment, to perceive the environment, we design and develop, implement the perception algorithms. So these perception algorithms enable the down modules like decision making, path planning, and vehicle control, and so on, and give us a safe driving autonomously. So how we are going to perceive the environment? Like human eyes and ears, I need to mimic it. So how I am going to mimic it? By using sensors. Sensors, what are the sensors I can use? I can use cameras, radars, lidars, ultrasonic thermal sensors, GPUs, IMUs, etc. These are the different sensors that are used to perceive the environment in order to mimic human ear and eyes. So these out of these sensors which are listed here, I can say cameras, radars, lidars, ultrasonic, thermal sensors are used to perceive the environment, whereas GPS and IMU is used to understand where I am in this real world. So for the vehicle to understand where I am currently, GPS and IMU will help us. So it will not only where I am, it will say like what is the speed of my vehicle, at what speed I am going currently, and in which lane I am going, and which what is the in which location I am currently. So all this information can be get from GPS and IMU data. And other sensors, cameras and thermal sensors, mostly more cameras is basically RGB image, and thermal sensor is basically IR image. So camera can support RGB images, can support complete perception, but it does not have the depth information. It has only the 2D information. So it can give the complete, it has rich information about the environment, but it cannot give the depth information. If depth information is not there, it is very difficult to understand at what speed the other obstacle on the speed is moving around. At what speed other obstacles in the environment is moving around. So we need an additional sensors like radar and lidar, which can give us the other vehicles velocity and the exact 3D position in the world. The depth information can be taken from there. Ultrasonics is basically used for the understand the nearby. If I am especially in the parking scenarios, if I want to park the car, I want to understand is there any curb near to that one. So those information is very difficult by the camera to capture, because when you go near to the curb, the camera, it's very difficult to understand what is there in that nearby surroundings. So in those cases, ultrasonics can be used. So these sensors, thermal camera, ultrasonic, lidar, radar cameras, all these sensors are used to perceive the environment. So what we have here, it has a huge volume of data. I'm not going to use one camera, one radar, one lidar, one ultrasonics, etc. for perceiving the environment. It will not give me the data. I will be having multiple cameras placed surrounding the ego vehicle, multiple radars surrounding the ego vehicle. Ultrasonics itself, I will have 16 ultrasonics surrounding the ego vehicle. Thermal sensors is basically for night vision during the night time in order to see the environment. So like that, if I have multiple sensors, I have a huge amount of data already collected in order to achieve the perception. So all this data will be structured or unstructured data. When I say unstructured data, it will be like radar cannot be, it's a signal. Radar and lidars are signals basically. Cameras and thermal sensors are image based. So we don't have a structured information from any of these sensors. All are unstructured data. And similarly, it is a continuous streaming. When I want to the real time, I can't store the data and play later offline. So it has to be on a real time data. So it has to come continuously. Data will be streaming continuously for the processing. And also I need to process it immediately and take a decision immediately. I can't take a decision after a minute. Yeah, everything would have happened by that time. So decision making, to make the decision making instantly, I need to process all this data instantly within microseconds or even microsecond level of processing is needed. So all these challenges we have when we talk about this huge amount of data and huge volume of data in the real world. So now why I'm using these many sensors? Because each sensor has its own advantages and disadvantages. As I told, camera sensors will not give the depth information. Radars and lidars will give the depth information and position information, but they are not rich in the rich in the information. Thermal sensors, definitely it can handle only the night scenarios better than the normal camera. So in order to combine the different advantages put together, I can have an effective perception solution. That's why we are going for a multiple sensors in order to see the environment. So in order to have an intelligent system that can perceive, interpret, and take a decision on itself, my sensors play an important role in order to mimic the human eyes and the ears. So data science pipeline, we have multiple, as I told, we have a huge amount of data. So this data, we need to collect it. Not only collect the data, we need to annotate it. Annotate it is basically labeling. I have a vehicle there, I have a pedestrian here at this location, at this distance, and they are going at this speed. All this data will be labeled, and this data will be prepared for model training. So once the model is trained, it will be optimized in order to put it to an embedded environment. Once it is ported to an embedded environment, the solution needs to be evaluated in real time on the vehicle, and the feedback should be given to the AI model so that it can improve the performance. So finally, it has to deployed in the vehicle. When it is deployed in the vehicle, it needs to be tested in the real time. And from there, it needs to be, we will get the feedback. And based on the feedback, we will be trying to again do the data capture and do this cycle process. This process is a cycle in nature, so that we will have a continuous learning. So AI model is also tend to learn continuously like a human brain. Human brain is learning every day. Like that, our AI model should be learning every day based upon the live experience from the vehicle. So this is how the complete data science pipeline work. Though it is a very very complex in itself, but we have a lot of challenges involved here, mainly because of the labeling. Because I have a huge amount of data from different sensors, I need to label each and every data so that my AI model is better than human intelligent. So there is a labeling, huge amount of labeling cost is involved, and it is expensive and it is time consuming. So it is very difficult for me to plan it for over a period of time and do the labeling, do the model training, and do a feedback iteration of the model to improve the accuracy. And also edge cases. It's very difficult to capture all the edge scenarios, like having a heavy snow, dense fog, heavy rain. So these are extreme cases which I can, which we can see encounter in a day-to-day driving scenarios. So in those cases, it's very difficult to capture the data for those critical scenarios. And also bias, of course. So if I have a model, if I have a data captured in Europe, my model will work effectively in Europe region. If I have a data captured in China, Asia, my model will work only in the Asian region. So it is biased. So based upon the data that is captured, it is biased based for the geography, and also about the lighting condition. If I capture the data in the daytime, my model is very good performance in the daytime. If I have a huge amount of data in the night condition, I can have better performance in the night. So it is based upon the data that is captured, our model performance also improves. So if I have a better quality, high quality data, I can say my model is capable to do more. That is what when we say about the data pipeline. So coming to the architecture, just I want to introduce what is the basic architecture we use in automotive domain. So already I introduced what is sensors. Sensors is used to see the to perceive the environment. Then finally, if it is an ADAS solution, I have a driver, and it will assist the driver. So how it will assist? Either it will be have an head unit display, where whenever there is a risk of collision, it will give a warning signal on the HMI. Otherwise, it can create an alert by introducing by ringing producing a sound or vibrating the steering, etc. So these are the input and the output. So in between, I have an ADAS software where the complete algorithm, what is designed for a particular ADAS feature, will be implemented, and it will be run in the hardware. This is the AI architecture for the ADAS. So when we say autonomous driving, it is something different. It will not it will not give any alert, or it will not give any warning signal. It has to control the vehicle. So along with the perception, I will have a planning module. I will be having a control module. So guidance and navigation. So for sensing, the same sensors can be used to perceive. I can use an AI-based algorithm to perceive the environment, but I need two more modules down the line to make a decision, and also to actuate, to control the steering and the brake and the accelerator. So these two modules added together constitute the complete architecture for autonomous vehicle. So perception, already I introduced what is perception. Planning and control is basically to do the path planning and the motion planning of the ego vehicle, and control based upon the other vehicle's behavior and the own vehicle speed and the location. We should be able to control the vehicle, reduce the speed of the vehicle, control the steering, change the lane. All those things can be done by the control module. So what I see, it's done by perception algorithm. What will happen will control by the decision making algorithm. What should I do will be taken care by the control module. So I will briefly introduce what is the perception system. Already I told my complete expertise lies on the design and implementation of perception systems. So I will be giving a brief, or another 10 minutes we'll be talking about the perception system. But I will give a insight towards the rest of the modules for you to take it forward at your own interest. So perception system, LiDAR, camera, radar, ultrasounds, all these sensors are used to perceive the environment. So finally, what is the output of that one will be the, suppose I am a driver, I am driving the car. When I am driving the car, what is the information I will look for? Is there any vehicle in front of me? Is there any vehicle that is coming behind me, which is trying to overtake me? Is there any pedestrian walking around? Is there any animals crossing around? Is there a traffic sign light is on there? Am I going in the right ego lane? Is there any other lane? Whether I need to take a turn, etc. This information, whatever I observe while I am driving, will be generated by using all these sensors. So each sensors will be processed independently in order to extract a certain information. So that's why I told LiDAR I can extract the position information and the dimensional information of the object in the real world. That can be extracted from the LiDAR. Monocular camera or stereo camera, a pair of camera can give me whether an object is there in 2D and whether what object it is, whether it is a car, it is a bicycle, it is a motorcycle, it is a pedestrian. So what kind of object is there in the road will be given by the camera. Radar can give me the speed of the vehicle, at what distance the other object is, whether the object is moving or not. That can be given by the radar. Ultrasound is basically to sense the near, whatever the near surrounding near to the vehicle, whatever the obstacles are there up to 8 meters, it can give the data. So what is that one will be given by the ultrasound. So this information is basically used for by the AI algorithms like object detection, object classification, lane, road classification, traffic sign. So all this information will put together in a sensor fusion module where all this information will be fused. So I can combine the information from radar, LiDAR, camera, ultrasound and put together to give a complete representation of an object in the environment. So if an object is there in the environment, I can give the information like what is the object is there, at what distance it is, at what speed it is going on, and which object is there, and what is its behavior. These things can be interpreted and extracted from combining all this information. That will give only the obstacles that are active in the environment, but I want to know the other static environment. That will be generated by using occupancy grid map. Occupancy grid map gives the static environment, where my road edges. Is there a building? Is there a tree? Those are static environment. So all these informations will be put together to give the perception system. So this perception system is responsible for developing the complete environmental model surrounding my EVO vehicle. So there are multiple things which we can do here. So deep learning is mostly used for perceiving the environment. So I have a sensors, give the complete representation, and I have an AI ML model in order to predict, interpret, and give me the data for the down modules. So object detection is one of the AI-based algorithm where we can detect the objects in the environment. Object include all kind of objects. Lane detection and classification. What is the lane detection? So you have different markings on the lane in order to indicate whether it is a single lane, double lane. So all this information can be extracted. And similarly, traffic sign is another module where we can understand what is the traffic. If you want to go at a low speed, 30 kmph is only allowed in that road. That can be read by using traffic sign recognition. Tracking is basically, we want to understand the behavior of the other vehicle. So we want to track the vehicle, how the vehicle is moving, whether it is trying to take a overtake of my vehicle. So it will give a complete 3D representation of the environment. So vision sensors, we have monocular. Stereo is a combination of two sensors. Infrared already I told, it is a night vision. All these camera sensors operate at 5 FPS to 60 FPS. So we have different processing in the camera. Once I have the image, I have pre-processing, I have segmentation, I have detection, object detection and tracking, and I have depth estimation, and finally it will give to the ADAS system. These are the different use cases for vision-based ADAS system. I want to understand 2D, 3D surround view. I want to understand what is there on the surround view. It will give the surround view system. Driver monitoring system, whether driver is drowsy, whether he or she is feeling sleepy. So it will give the driver monitoring system, it can give that. And also it will, camera monitoring system, static camera can be used to monitor the entire environment, object detection and classification, traffic sign, lane detection, all these things can be achieved by placing a camera surrounding the EVO vehicle. So what is a neural network? I don't want to spend much time on the AI-based concepts, just I will give you an idea. So neural network or deep learning, we can say like a human brain. So how the human brain trains, when we are born, we are shown to different obstacles in the environment, and we are introduced like this is cat. This cat is brown in color. This cat is has some white color patch on it. The other cat, it is white in color. So like that, we are introduced to the kids like, oh, we are seeing multiple objects in the environment. Like that, our human brain is getting trained. So like that, This neural network is an algorithm which will be trained by giving certain inputs to the algorithm, and it can detect the it can able to recognize that one when it sees again. So there are different layers in the algorithm where each layer extract different levels of features, and these features are put together in order for the algorithm to gain the intelligence and recognize what is that object is about. So basic building blocks of neural network are convolutional layers and activation layers, pooling layers, all those things you might be aware of. Just we have if I say a deep neural network, we have an input layer and output layer. In between input layer and output layer, we have multiple hidden layers. So each layer will have a combination of this convolution layer, activation layer, and pooling layers. So convolution layer basically to extract the features from the image. So initial layers can extract very minute or details like edges, corners, or etc. from the image. When we move across to the higher layers, it will start extracting more information, like forming a human face, forming a complete object data. So this features that are extracted by the convolution layer or actually given to the activation layer and to the pooling layer in order to handle the size of the features, so that it can be handled by the next level of layers. So basically, this neural network is trained by using a backpropagation algorithm, where we will train the algorithm so that a certain parameters is getting trained, and that parameters can help us to later to recognize the object that is trained by the network. So this is the basic. Already we spoke about what is convolution layer, pooling layer, activation layer, all these things put together. So when I give an input as an image, from the image, it will extract the features layer by layer. It will extract the features, and finally, I will have a fully convolution layer, and which can help to recognize what is the object present in the image. So we have just why I want to give the background here is I want to introduce practically how we can handle this AI model and train this AI model. We have two different parameters when we train this algorithm, that is parameters and hyperparameters. Parameters is basically by weights and biases that are getting trained when we train the model, where hyperparameters are set before we train the model. So hyperparameters is normally set externally, but parameters are weights and bias are which is getting trained when we train the algorithm by using the training data. So there are several hyperparameters. This hyperparameter tuning will help us to make a particular AI model suitable for a particular application. So when we need to train for a particular application, you need to tune this hyperparameter, then train the algorithm for weights and biases. So practically, when we want to tune the hyperparameter, normally when I have the data, based upon the amount of data what I have, I can have the split between the training data, validation, and the test data. If I have a limited amount of data, I can have 60%, 20-20, which is normally we use it. When we have a big data, huge amount of data is available, we can make it as 98 and 1% and 1%. This is actually an iterative method. Like when you have an idea, you have the data, train it, test the performance, and then again tune the parameter, and then train again to improve the performance. So there is a high chance for us, like we are using a different training data and different test data, but we have to ensure like the proper bias should be there. Balanced data set is what will give us a best AI model that is suitable for best application. So for example, I am training a model by using some images that are downloaded from the internet, and later I'm testing it on a mobile camera. Then definitely you can see the difference in the model performance. But when you prepare the data, you should have a balanced data so that it can have whatever the performance you do during training, you're seeing the performance, the same performance you can see on the vehicle or the end user perspective. So you should have a bias or balanced data here. So basically we have bias and variance. So when we have underfitting, it introduces high bias. Overfitting, it introduces high variance. So you can't have a model too complex to fit to have a high variance, but you can't have a model to be too lenient so that it will have a high bias. So how can you understand that one? By using an error. So training set error, you have a training and development set. If the error between the training and the development set is huge, then you have a high variance. If it is very low, then you have a low bias and low variance. If you have a high error in both train and development set, it will have a high bias. if there is a difference in these two, you have high error, and there is a difference between these two, training and the development error. You have both high bias and high variance. So you have to be very careful in selecting this error. So there is always a trade-off between bias and variance. You can't have always low bias and low variance model. You will have you need to trade off between these two parameters so that the model performance is good enough for realization. So when you have a high bias, then you should go for a bigger network. When there is a high variance, you should go for a more training data. So when you go for a bigger model, you need to go with a more advanced regularization method, optimization method, so that you can address this high bias issue. When you have more high variance, you should go with a more data. So your network is better, but you need more data for make it better. So in this era, means whatever we are currently now, to have a huge amount of data and you have a huge amount of network is what normally leads to low bias and low variance network. So this is a multi-object detection where you can see like there are traditional methods. When we before deep learning era, what we did is I have an image, I extract the feature and I give that features to a machine learning network, which will classify and give me whether there is an object or not. But that is not the case with the deep learning. You know, the feature extraction and classification, everything are done by the model itself. So there are several models, like you have single shot models and two-stage models. Two-stage models are more good in accuracy, but they are more complex in nature. One-shot methods, they are less in complex, but they have reduced performance. So of course, to go for a real-time realization, I need to go with a model that is not much complex to implement in the real time, but I can compromise a little bit on the performance. So again, a trade-off is here based upon the embedded device on which you're going to port the model, the performance on which you're working. You need to compromise the model performance and also the model structure. That is what I am intended to say here. Like there are different models available in the literature. It doesn't mean that you have to go with always a higher end model that will give always a better performance, but it may not be able to realize in the embedded system. So we have to compromise all these things, and then we have to select the best model for our application. So this one already we discussed what are the different AI-based perception systems we have: object detection, traffic sign, lane detection, pedestrian. So many things are there which are based on camera, LiDAR, radar, and ultrasonics. And what will happen? So we discussed about camera-based perception system, but we are discussing about LiDAR, radar, and other things. So only having a camera-based system will definitely not help us to achieve a fully autonomous driving or complete perception. So I'm going for a different sensors like radar and LiDAR. So what finally I'm going to achieve it? So in case of object detection, camera has a medium performance, but radar and LiDAR has a better performance because it is a real world data. So you can have the detections in the real 3D world detection itself you can have. So actually what is the takeaway from here is like with one sensor, you can't achieve the performance which is needed for autonomous driving or ADAS feature. So you have to go with more than one sensor. It can be a same sensor or a different sensor. Same sensor, I mean multiple cameras can be used, or camera, radars, LiDARs can be used. So going with the multiple sensors definitely will increase my performance in pursuing the environment. So definitely one sensor, it will have its own drawback. It will have its own advantage. So by going with multiple sensors, I'm combining the advantages from different sensors. I'm utilizing that information in order to have a better perception. So that is a meaning, like each sensor, what it is good in which and how it can be useful, how it can be combined to get a better performance in the autonomous environment. So that's a multi-sensor fusion. Multi-sensor fusion is another topic in perception domain where we can combine all the sensor data in order to get a complete perception. So this is one example I can show you here. The blue color is a complete camera-based solution, like all 360-degree we can have the perception. This green color is for example, take a radar. So you can have, if I have a radar, I can see object only in the green color FOV. But if I have a camera, I can have the object surrounding the environment. So when I fuse these two information, I can have an idea of the object surrounding the environment. That is the advantage of going with the multiple sensors and fusing the data in the environment. So here in the next one, you can have orange, green, and pink color. So each one represents the FOV of individual sensors. So when I'm combining these two, combining all these sensors data, I can have the complete environment information for making any decision. That is called sensor fusion. It is basically to generate a complete perception surrounding the ego vehicle using multiple sensors data. So this is the generalized architecture of sensor fusion. So where you have multiple sensors here, and these sensors along with the vehicle information, we have the complete perception module, which will detect the obstacles and fuse the obstacles. So I have separate object detection algorithm for radar, for camera, and for the LiDAR. All this information are used are fused here by using a classification information. So finally, from the fusion, I'm getting a single representation of the object that is present in the environment, that is tracked in the 3D, and this information is given to the environmental model or for the decision module to take the decision. So whatever the output from the perception fusion module is going to be the combined representation of the environment. So this is the advantage of having a fusion. So red color bounding boxes are from one sensor and green color bounding boxes for the other sensor. So if you combine these two information, you can have a single representation of the object, and you can remove all the false positives. You can see the red color bounding boxes on the other environment. Those are false positives. Since we don't have the information from the other sensor, we can reject all those things. So you can have the false positives eliminated, and I have a single representation of the obstacle that are available in the environment that you can see in the right side one. So this is by using all these sensors, we are seeing the environment. So we know what is there in the environment at this stage. So how to decide? So car has to decide what to do next. So how it can decide? By using a decision making, guidance and navigation control module. Basically, it takes the input from the perception module, or whatever the output from the perception module goes as an input to the decision making, guidance, navigation control module, and using that information, it will localize itself. I will understand where I am in the environment, and where I will place other obstacles that are seen in the environment surrounding my vehicle, and I can have a complete perception of my environment, that is localization. And based on that one, I know where to move from point A to point B. So based on that, I will decide the path. Once I have the path, I will understand whether I need to change the steering, whether I need to control the speed, whether I need to apply the brake or actuator, increase the speed, whatever it is, I can make a decision. And then I can start controlling the vehicle. This is how the guidance and navigation module works. So, so far, till before the deep learning era, I can say we have used mostly rule-based or deterministic approach or probabilistic or simple probabilistic approach in order to control, in order to do the path planning, or in order to do the motion planning, in order to make a decision. All simple deterministic approaches were used. But since we are in the deep learning era and we have huge number of data, in localization, we started using CNNs, RNNs, LSTMs, etc., which will give us an idea about temporal information also. It will take and work on it. And path planning and motion planning, decision making, reinforcement learning is big breakthrough for us to understand or make a decision based on the perception input, and probabilistic based approaches. And in case of vehicle control itself, normal pit control was used before. It was like a rule-based controllers, which is used for controlling the steering, brake, and the acceleration. But when we have a huge data, we have AI-enabled algorithms that are learning-based controllers are in place now for us to control the vehicle autonomously using AI-based solution. So basically, what we want to say is like not only the perception algorithm, down the model for guidance, navigation, and control as well. AI helps to transform the performance of the algorithm intelligently for real-time applications. Finally, the deployment in the vehicle. So I have the AI model trained by using all the sensors data. And next thing, what I can do. So normally, whatever we work in the research, till AI model training, we'll be working. And after that is a black box for everyone. We are working in the academics, like how this model is taken into vehicle and tested. So what are the next steps we have? So deployment is the one which bridges this AI research, whatever output we have, to the real-time implementation. So yeah, I have an AI trained model. Next one, I need to put it to an embedded environment. So embedded platform is something like you might have learned about microprocessors, microcontrollers. Now we have more advanced processors from by Qualcomm, NVIDIA, TI. So these processors are enabled with AI support. So we should be able to implement or scale the AI training model to that particular embedded application. For that, we will go for model optimization. Model optimization, When we run the model on the PC, we can run with any precision. But when I want to put it to an embedded system, I need to restrict the representation of the numbers. So that is quantization. So once it is quantization, the model size, whatever the model size I'm using, I should be able to prune it, and then I can use it effectively in the embedded system. Of course, there will be a compromise on the degradation performance, which we see in the AI model, which is already trained, but that degradation should be watched. And if it is acceptable, we can definitely go with such levels of quantization and pruning. So once it is done, model optimization is done, it will be loaded to the embedded platform, and finally it will be validated there, and it will be integrated to the vehicle along with the other systems. Not only the perception system, we have the other systems there. Along with that, it should compatible to integrate with other systems in the vehicle, and finally it has to be tested in the real world. This is how the complete AI trained model is deployed to the vehicle. So it is easy to say in a single slide, but there is a lot of complexity or challenges involved in porting or in deploying any AI model to the vehicle. What are the challenges we have? Definitely latency is one of the challenge. So I can get the data from the sensors at this particular time instant. My algorithm can take this much time to process the data and give me the data. And once the perception, so for example, I am taking 100 millisecond by the perception algorithm to give me the data, then that 100 millisecond will will be taken by the other modules in the system to deliver to the final steering. So it may take, so for example, the latency is 200 millisecond. So is the 200 millisecond is good enough in the real time to react for a critical scenarios, is what is a really challenging one. If it is an ADAS, this second can be acceptable. But if it is an autonomous vehicle where we have to take a real-time decision, this has to be handled. So of course, if I have a false positives, if there is no vehicle, but model is giving us a vehicle, then it is also a critical issue when we go with an autonomous vehicle, which has to be handled. That will be handled only by the model. But model, how it can handle? It can handle only by having huge amount of data. So everything will be in loop. So next thing is the safety. So if this model is deployed in the vehicle, we have a lot of functional safety standards that are available for the automotive industry that has to be satisfied in order to ensure the reliable implementation of performance of these algorithms in the real time. So what are the key technical challenges here? Definitely training the DL network for complete environmental perception is a key challenge, because whatever the human undergo, if we are driving in India today, when we go to a foreign country like Europe or US tomorrow, we definitely will face a problem to start with the driving there. So we need some kind of training there. Our human brain needs some kind of training there in order to accommodate to that environment. So that diverse data set, we can't have a diverse data set from the environment or the complete world to have a unique solution for the autonomous vehicle. So that is definitely a challenge here. And adverse weather condition is another challenge. In India, we will mostly see summer. We won't see snow, fog, intense fog. Those are very rare climatic conditions for India. But for the other countries, snow is another big barrier. So like that, different weather conditions, accommodate different weather conditions is also challenging. Different lighting condition, all the sensors will not support in all lighting conditions. Camera, RGB camera, you can see only daytime, it needs a light as an input source. Radar and LiDAR, it can work during daytime and nighttime, but the performance is not as good, as it will not have the complete information what camera has. So we need thermal camera, which will give for the night perception. So different conditions, when there is no light at all, there is no even a single light in the environment. If my vehicle needs to perform, I need to have data in such scenario, which is annotated, labeled, and the model is trained for that. And we need to go with a functional standards, safety standards to be satisfied, which is a very toughest part to bring any perception solution for the real-time applications. So we need multiple sensors. So definitely the volume cost of the vehicle will be increased, which the consumer is normally hesitant to take up that one. So we have to see in every aspect, we have to see how the solution can be better used by the consumers. So fully autonomous driving, coming up with a fully autonomous driving has a lot of challenges in it in terms of end-to-end learning. What next we have here? Vision language action model is one which is currently everywhere we are working on it, because we need to end-to-end solution. I don't want an AI-based solution separately for a perception algorithm, AI-based solution separately for a guidance algorithm, AI-based solution separately for a decision-making algorithm. No, I don't want something like that. I want my algorithm like a human brain. Like when I see an object in front of me, I'm able to decide what I have to do immediately. Like that, I want to have an end-to-end deep learning algorithm which can detect, recognize, interpret, and it can understand, take a decision, take a control, and give the proper planning for the system. So I need to have an end-to-end learning solution, which is currently researched by using vision language action models now, which is basically human-like reasoning is what it is expected out of that one. Explainable AI comes under this category. The next one is the software-defined vehicle architecture. So whatever we have, we are talking about porting the algorithm to an embedded platform. An embedded platform, suppose today I have a BMW vehicle with a high-end perception solution in it. Suppose if I move forward after, means like after 5 years, my vehicle which I bought today, BMW vehicle with that many lakhs of cost involved, I can't use it with the features that are available after 5 years with the current BMW vehicle. If I want to go with, if I want to utilize the features that are available after 5 years, either I have to sell this BMW vehicle and go with a new vehicle that is available in that period. But I don't want that. Why I have to waste my money in 5 years? I am already investing lakhs of amount in BMW vehicle today. And in after 5 years, I want to use the same vehicle. How can I use? Software defined vehicle is one which can help us. So it will help us to update the softwares on air. Like you need to update the softwares alone, you don't need to change the vehicle. So this is also the concept which we are working on moving forward in the current scenario. And of course genetic AI and self-supervised learning. As I told before, to achieve any perception solution in the world, we need labeling. Labeling is high cost and it is time consuming. I don't want to label the data. I don't want to invest money in that. I don't want to spend time on it. So how can I do? On the go, my algorithm should be able to train by itself. That is done by using a genetic AI without labeling and without supervised learning. So the final thing is synthetic data. Synthetic data, of course, which will be helpful for the current scenario because we don't have all the corner cases or critical cases that are available in the that can be faced by a human driver available as a data set. So in order to mimic or in order to synthetically generate the data that is needed in the current scenario, synthetic data generation also help us a important role in order to make this AI system realizable in the real world. I think that's all. I am done. I think thank you for everyone for listening to me.
Thank you, ma'am. Excellent presentation. It was really very, very interesting in the current scenario.
Thank you, ma'am. Sorry, I was running fast because a lot of things to convey.
Yeah.
So I was running fast. Any doubts, you can come back to me anytime.
Okay, few questions from what I wanted to. We have lot of sensors now controlling the vehicle.
Yes, ma'am.
So how do we ensure that all these sensors are working correctly and the data is being collected and the system is working fine?
Good question, ma'am. Actually, how we are handling that one is like, say, whenever I have a data, I will be having along with the timestamp. So if I'm having a camera data, the current time instant will be stamped along with the data. So I will use the timestamp information in order to fuse the data from the other sensor for that particular time instant, and also to understand if there is a data in the time, if there is no data in the time instant, we will not consider that one. So time instant means time data will be also associated or sent across the other sensor data. That will help us to sync.
Okay, so in case some camera or any sensor is not working, then we'll be able to identify using the timestamp.
Now,
Am
if
I
it
right?
is not working, so there are two cases, ma'am. First case is like timestamp is used to understand sync the data across different sensors. And
Okay.
it also helps to sync if some of the sensor data. So I can't run camera, radar, and LiDAR at the same time instant. So camera can run at 40 millisecond, LiDAR and radar can run at 50 millisecond. So every 40 millisecond, if I fuse the data, I will get at the first instant, I will get only one data from camera. But at the next time instant, next 40th millisecond, I can have data from camera, radar, and LiDAR. So that is how the timestamp is used to fuse the information across different sensors. When we say whether the particular sensor is working or not, we have a logic like error handling mechanisms in order to continuously monitor whether there is a continuous stream of data coming out of the sensor. If there is no continuous stream of data coming, this is a separate module that will not come under, that's why I told along with the perception system, we have other systems also integrated. So those error handling systems will monitor whether these sensors are streaming continuously or not. If it is not continuously streaming, say it will wait for 5 minutes, it will wait for 10 minutes. If it is not, data is not coming, it will definitely pop up saying that the sensor data is not working.
Yeah.
So that is error handling concept.
Okay. Okay. Then about okay, as of now, might not be here, but in other countries, there is a mixed set of vehicles. Now, few vehicles are autonomous, few are manual. So there are a lot of mixed set of vehicles on road. And in case someone from the back of our vehicle is an human driving, and they make some mistake and hit us from the back, is there any safety mechanism to avoid or to
these safety mechanisms are, sorry ma'am, these safety mechanisms are to protect our vehicle and ourselves. If
yes,
somebody else is doing an error, we can't avoid that one, right?
okay,
That is not possible. So I can be like, for example, if I can interpret that the vehicle is coming at a different speed and come and hit to us, either we can increase the speed and move forward and go to a different lane. Those decisions can be made, but instantly when it is happening, it is very difficult to handle that complex scenarios.
okay, okay. So very nice presentation. It is an eye opener. So to see things happening. Okay.
Thank you so much.
Thank you. Sir, any questions from mothers?
Actually, really very nice. Given that very good explanation. Ma'am, if in future, if the students, they may need any help to do the project, can you support to the students, ma'am?
In this domain, I can support, sir, but if they come with a different domain, I may not have some.
Regarding the same project, right? Because some of the project, it may be relevant with that some AI based, like that means, why? Because actually that all the sensors may be connected with that AI. So it may be in future work, like if the students may be interested to do, we will approach you, ma'am. If it may be possible, try to give some ideas. It may be helpful to the students.
Sure, sir. Definitely, I can. To my knowledge, whatever I have, my expertise, definitely I can support.
Sure, sure, ma'am. Sure.
Thank you. Sir, vote of thanks.
Yes, ma'am. Good morning to everyone present here. It is my privilege to present the vote of thanks for today's enlightened session, generic talk series from data to decisions, AI in the autonomous driving and ADAS. First and foremost, we express our sincere gratitude to Dr. Suganthi Srinivasan, ma'am, Senior Product Technical Lead, Valeo India Private Limited, Chennai, for delivering such as insightful and enhancing talk. Your expertise and practical insights into AI applications in autonomous driving and ADAS have truly enriched our understanding and inspired our students and faculty. We are deeply thankful for your valuable time and for sharing your knowledge with us, ma'am. We extend our heartfelt thanks to our management, principal sir, and our HOD ma'am of RMK Engineering College ADS department for their continuous support in organizing such meaningful knowledge sharing sessions. Our sincere appreciation goes to all the HODs, faculty members, and students who joined us today, made this session successful through that entire participation. We also thank our organizing team and technical team for their dedicated effort in arranging this live streaming through the RMKEC YouTube channel and ensuring that the smooth conduct of this program. Finally, we thank everyone who contributed directly or indirectly to make this event grand success. Once again, I thank you all for your presence and participation. Thank you, ma'am. Thank you, one and all.
Thank you, ma'am. Thank you.
Thank you very much, ma'am.
Thank you, ma'am.